A human is at the top of the food chain. Not because we're the biggest, because size doesn't matter, but the question is, why are we at the top? We're just the mega nerds of the animal kingdom. Which leads me to a thought experiment. Do brains actually beat brawn? How strong can a person get? Using incredible science and a complete lack of a moral code, we're going to use this handsome fellow as a lab rat. His name is Kevin.
Hello.
Hello, Kevin. Don't worry, Kevin has no feelings and feels no pain. First, I'll cover the creation of Kevin. And I know this is derogatory, but he's a GMO. Kevin was created using the cutting edge in genetic modification technology. His genes, and I'm not talking Wranglers, are perfectly molded to maximize force output. He, as a genetically modified organism, has harder bones, stronger muscles, and faster muscle regeneration than any modern human counterpart. Kind of like steroids, but since birth. Speaking of, what kind of mad scientist would I be if I didn't expose Kevin to possibly severely damaging synthesized hormones? In the late 1930s, the first steroid was invented by a German scientist in an attempt to treat hypogonadism, otherwise known as testosterone deficiency, which eventually led to Nazi experiments.
Hello.
Hello, Kevin. In the 1960s or so, countries fed their Olympians steroids like candy, leading to a ban on the substance. Fast forward to now, and there's a huge range of steroids to choose from, each one more potent than the last. And some are extremely illegal. But for our purposes, we have access to the full smorgasbord, as this is all hypothetical. Anyway, eat this. Most steroids are a replica of testosterone. This one is no different. It should boost the effects of testosterone in Kevin's system, leading to some side effects we'll discuss later, but also leading to larger muscles and stronger bones, which means Kevin is now 20% stronger than he was 2 seconds ago. But those are rookie numbers. Look at him. Pathetic. In order for the roids to work, and I'm not talking hemorrhoids, he needs to hit the gym. Not just any workout either, we're training for strength. To train effectively for strength, he needs big weight, as heavy as he can lift for 5 to 8 reps.
Hello.
Hello, Kevin. Also, trying to keep exercises to the big...
Hello.
Hello, Kevin. To the big muscle groups. Legs, chest, and back. Squats, bench press, and rows
Hello.
are the best examples of these. Strength is not only how much weight your muscles can handle, but how much leverage you can accumulate. These workouts use multiple muscles, which means Kevin will learn how to use his whole body effectively, and thus lift more weight.
Hello.
Alright, Kevin. Get into the
gym beyond time
and do exactly as I said. Also, eat vegetables, protein-heavy foods, and get plenty of sleep. The
gym beyond time
is equipped with a kitchen and beds. Otherwise, it wouldn't be
the gym beyond time.
Hello.
No, not 70 years. Stupid.
Hello.
Kevin is now 50% stronger from his time at the gym. I could have had him in longer, but unless we're changing something drastic about his plan, the first few years are going to see the most change. Don't worry, we're far from done. An average person has access to 40% of their total muscle potential. This is because of the neural inhibitors the body has in an effort to prevent you from using too much force and hurting yourself. Say, when kicking something, you don't accidentally shatter your shin. And trust me, you can. Look at this. In 2006, a mother wrestled a 700-pound polar bear to protect her children and escaped with minor injuries. 2019, a teenager lifted a car off his neighbor. 1982, a woman in her late 50s lifted a nearly 2-ton car and kept it suspended for 5 minutes straight. 2013, another vehicle, this time a Jeep, lifted up a 75-year-old man. All these people normally have access to only 40% of their musculature. 40% is increased to 65% given consistent training, which means even on gear and having spent 7 years training hard in the gym, Kevin is only operating at about 65% capacity, to be conservative. In short, Those little neural inhibitors up in your brain hole gonna have to leave. Unfortunately, we can't remove neural inhibitors by force or using surgery. Can't delete a neural pathway or whatever. We can make those limiters go away using drugs. A cocktail of adrenaline, cortisol, and endorphins causes the human body to use 100% of its muscle capacity in times of emergency. So, hopped up on steroids, time in the gym, eating well, and just a smidge of adrenaline, Kevin now has full access to his genetically modified muscle potential. Welcome back to the Side Effect Corner. Possible side effects of steroid use and adrenaline usage include difficulty sleeping, put damage to nerves, being a whiny poopy pants baby, acne that results in scarring, acne that is there, shrinkage of dillberries, impotence, gynecomastia, you look that one up, baldness, liver disease, shortness of breath, anxiety, sweating, abdominal cramps, headache, hypertension, and let's not forget the powder your bones and ligaments will be after massive muscle overuse. This has been the one and only time I'll ever do Side Effect Corner. Tune in next week, where we'll answer that question, how empty is Kevin's stupid fat head? But we're here for a good time, not a long time. And Kevin doesn't feel any of this. Do you, Kevin? Besides, we haven't even gotten into possible cybernetic upgrades we can give Kevin. The first of which that comes to mind is an exoskeleton suit. While there are many iterations of exoskeleton technology used for helping neuro or physically damaged individuals move, there are also versions developed for military and construction work. These suits have the capacity to amplify strength by around 20-1. Meaning a 100-pound load would feel like 5 pounds to the suit's user, which would be astronomical gains for Kevin. 2,000% over what the body is used to, actually. Unfortunately, there is a caveat. The suit has a 200-pound weight limit. I mean, I'd take an extra 200 pounds to my max, thank you very much. But why just wear the suit when we can become the suit? Introducing advanced prosthetics. Advancements in materials, robotics, and prosthetics technology could lead to prosthetic limbs being stronger than biological ones. They could be more durable, using materials like titanium or carbon fiber. They could be designed in advance to where the power of a prosthetic limb would be greater than a biological one. They could be customized to the user's needs, and the sensors and feedback would make it much easier to prevent damage to others and themselves. That being said, if we applied this to Kevin, we'd have to get rid of his awesome genetically enhanced limbs. So, I have a solution. I can't increase his strength by using prosthesis, but I can make him more durable. Those bones are getting an upgrade. Bones? Titanium. Titanium? Bones. Unfortunately, we can't replace all of his bones with titanium. He needs bone marrow to create red blood cells. However, knuckles and softer bones, like the clavicle, can be replaced with titanium, making his fists lethal weapons and his weakest parts completely defended, reducing risk of injury, increasing efficiency, and improving recovery. Speaking of, we've increased Kevin's strength to astronomical levels. However, if he was ever in a fight, his defenses are sorely lacking. This is where things get a little nutty. A quick fix to this problem is a cutting-edge technology known as nanobots. A new technology used mostly in the medical field would be so small they could be injected into the human body. They're usually used to target and eliminate diseases that our immune system would normally have trouble with. Not only this, but they have the capability to repair muscle fibers. I think you can see where I'm going with this. Making nanobots a kind of regenerative superpower for Kevin, meaning any more training for Kevin would result in quicker gains and any actual damage to his body could be repaired. I don't know if he should rely on them medically, but it would help them a lot. An average human body has access to 40% of its natural musculature. With proper diet and training, it's increased to 65%. Steroids increase this number even further to around 85%. Hysterical strength by use of adrenaline, 100%. Exoskeleton, 145%. We're not working with an average person. Genetically engineered, this percentage increases by at least an additional 30%, giving Kevin access to over 175% of his musculature. Bone reinforcements not only increase durability, but give structural support, increasing this to 195%. Nanobots increase this by accelerating muscle growth. Kevin now has access to a whopping 215% strength potential of an average man. Say there were two friends. One was 442 pounds and the other was an average human. That average human, under optimal conditions, can lift his friend, who is 442 pounds. While our boy Kevin here can lift approximately 1,200 pounds, or 2.6 times stronger than an average human. Anyway,